Okay, for this review, we're going to start with our PEMDAS problem. And for this problem, we notice that there are brackets and braces. So we're going to start with what's in here, and then when we're finished, we will go back to what's in here. And then we will include the -1, or the 1 minus that's outside at the very end. So first we're going to start with what's inside of here. And we have addition and we have multiplication. So we're going to do the multiplication first. So let's do 3 times -4, which is -12. We still have a 7 out here. We have a brace divided by and a 30 and a 1 minus on the outside. Then we're going to go to 7 minus 12, which is -5. We'll just bring down the divided by with the 30 here. And we have a minus and a 1 outside there. And our second to last step really is going to be to do 30 divided by -5, which is -6. And there's still a minus and a 1. These actually go to plus plus, and this gives you 7. So that's our PEMDAS problem. Next, let's go to this evaluate the expression problem. So we have to plug in our values that they're giving us for the variables. So y to the third power, or y cubed, will be 4 cubed. 3 times a times b plus 2 will be 3 times -2 for a times -5 for b plus 2. And basically we do these two as two separate problems, because the division bar will be the last thing we do. So the 4 to the third power, or 4 cubed, is 4 times 4 times 4, and that equals 64. 3 times -2 is -6, then we still have times -5, and we still have plus 2. Since we have multiplication and addition here, we're going to do the multiplication first, which gives us positive 30 plus 2, which is 32. And you might see that 64 is double the 32, so our answer is just 2. If you didn't see that right off the bat, then you could start dividing. So 64 divided by 2 would be 32. 32 divided by 2 would be 16. And you could keep going if you need to. 32, let's say, divided by 4 is 8. 16 divided by 4 is 4. And then maybe then you'll see 8 over 4 would give you 2. We're going to slide this down, go to the next two on this page, the last two on this page. And we have a solving the absolute value equations, and we will remind you to check your answers. So for this first one, we might recall that we have to get the absolute value by itself first. So in order to do that, we have to get rid of the 7. So since it's 7 times the absolute value, we're going to divide by 7. And divide by 7 on the other side, and we're left with the absolute value 4x minus 13 equals 5. And at this point, we have to say to ourselves, we have to remember that if you have 4 minus 13, I'm sorry, 4x minus 13, whatever that value is, could have been a positive 5 or it could have been a negative 5. So what we do here is we write two different problems. So 4x minus 13 could have been a 5, and 4x minus 13 could have been -5, because the absolute value of 5 is 5, the absolute value of -5 is 5. And then we just solve. So add 13 to both sides, and 4x equals 18. And if we divide by 4 on both sides, x equals, and 14 goes into 18 4 whole times, and then there's 2 left over out of 4, so it would really be like 4.5. And just remember that we asked you to write everything in an improper fraction instead of a mixed number. So 2 times 4 is 8, plus 1 is 9, so we'd make that 9 halves. That's your first answer. And again, we have a second answer. So if we add 13 to both sides, 4x equals 8. And then when we divide by 4 to get x by itself, x equals 2. So these are our two answers. All right. And next we have 3x minus 7 in the absolute value minus 5 equals negative 3. Now, let's pretend that we didn't have this negative 5 here. If we just had 3x minus 7 equals negative 3, there would be no solution for this problem because nothing in an absolute value can come out as a negative number. So right there you would stop and you would say that this problem cannot be done. However, we are going to keep going because we do have something we need to do before we check to see if it has a solution or not. And what that is to add 5 to both sides, and actually we will come out with a positive 2 is still equal to that absolute value of 3x minus 7. Now, like we said in the last problem, whatever's in here could have equaled a negative 2 or a positive 2. So here we split our problem into two equations. That 3x minus 7 could have been positive 2, and 3x minus 7 could have been negative 2. If we add 7 to both sides, we get 3x equals 9, and we divide by 3, and x equals 3. That's our first solution. Then we add 7 to both sides, and we get 3x equals 5. When we divide by 3, x equals 5/3. There are our two answers for this problem. Now, we did ask you to check these, so let's go back and check our answers. So, would 9 halves and 2 both be solutions? What's 9 halves and 2 both be solutions? So let's look. If we have 7 times 4 times 9 over 2, 7 absolute value, 4 times 9 over 2 minus 13 equals 35. This will go to a 1, that will go to a 2, so 2 over 1 times 9 over 1 would be 18 minus 13, a 7 out in front, equal to 35. 18 take away 13 is 5. The absolute value of 5 is 5, so times 7, does that equal 35? And yes, that does, so that's a check. Now if we test the 2, it would be 7 times 4 times 2 over 1 minus 13 equals 35. And let's check these and see if this works. So 4 over 1 times 2 over 1 would just be 8 minus 13, absolute value, with a 7 on the outside, so that's being multiplied. 8 minus 13 is negative 5. And the absolute value of negative 5 is 5. That times 7 does give you 35, and that's a check. So both of these answers did work. Now let's look over here and look at our two answers, which are, we're going to check 3 and 5/3. So our original problem was 3x minus 7 in an absolute value minus 5 equals 3, negative 3. So we're first going to check a 3 in there. So let's try 3 times 3 minus 7 minus 5 equals 3. And we do this first, so it's 9 take away 7 minus 5 equals, negative 3. I keep forgetting that negative. 9 take away 7 is 2, absolute value. The absolute value of 2 is 2 minus 5. Does that give you negative 3? And that's a yes, because 2 minus 5 is negative 3. And you can have a negative in that answer as long as we remember that we had to add the 5 to both sides in the beginning. So then we're going to check 5/3. So we have 3 times 5/3 minus 7, absolute value, minus 5 equals negative 3. And the way we do that is 3 is technically over a 1, so these two can cancel out. 5 over 1 is 5. minus 7 in the absolute value minus 5 equals negative 3. 5 take away 7 is negative 2. The absolute value of negative 2 is 2. Take away 5. Does that equal negative 3? And that's a yes. So that's the answer to that problem after we checked both of them. Okay, so let's go to a new color here. So now we have to solve the inequality. I'm going to slide this screen down here so that we can use all of this space that we have. Okay, so here we have to solve the inequality and, sorry, I'm just getting my screen right. Solve the inequality, graph the solution set on a number line, and describe the solution set using interval notation. So first we solve. Okay, so we have negative m is less than or equal to m plus 4 over 9. So the first thing we need to do here is get rid of the 9. So we're going to multiply 9 on both sides. That'll cross these two 9s out. And then we have negative 9m when we multiply everything equals m plus 4. And then we need to get the m values by themselves on the same side of the equation. So we're going to subtract m. Negative 9m minus a 1m, that's technically over there, is negative 10m. Oops, we don't need the 4 anymore, the plus anymore, so we just have 4 because these cross out. Now, we can subtract by m on both sides and not change our sign. We'll keep it exactly the same. But watch what happens right now. So if we're going to divide by a negative 10 and divide by a negative 10 on both sides, now the sign changes because we divided by a negative number. And when you multiply or divide by a negative number, you change the direction of the sign. You keep it equal to, but you change the direction. And 4/10 reduces to 2/5, and that's still negative. So here is your solution, and this is the answer for letter A. Next, we're going to graph this on a number line. I'm going to use black here. So we have to use we have to plot negative 2/5. So if this is 0, let's say this is 1, and that's negative 1. 2/5 would be a little less than half, so negative 2/5 would go about here. And we have a greater than or equal to sign, so we're going to close in a circle above the negative 2/5. And if it's a greater than, we're going to take the line and go in this direction. Because the greater than means that we're going to be creeping along this way where the larger numbers will get. This would be 2, this would be 3 in the positives, and down here we would go to negative and larger negative number, and which means that the numbers are decreasing. Okay, and then our notation for the last part would be our interval notation. Since we are starting at an absolute negative 2/5, since we can actually use that number, we would have a bracket and a negative 2/5. And in this direction that we're going here, we don't know where it's going to stop. So we will have an infinity there. And since we don't have a definite stopping spot, we have a parenthesis. And that is your notation. You should look back to some examples and see how we did that before. We have a lot of examples in your notes. And okay, so now we are moving on to relations. Okay, so first we have to graph the relation, and I'm going to pull out a tool here that we can use. Remember, if you go into shapes on NoteTaker, if you're using NoteTaker, you can pull out a grid. That's real handy, just like that. All right, and then we can have a nice graph. If you're like me and you have trouble drawing straight lines without a ruler, especially on the iPad, it gets a little tricky. So graph this relation. and state the domain and state the range. So you might want to make some of these notes when you get a problem, especially if it's an open-ended problem and not a multiple choice. Circle some of these things so you remember at the end you should go back and check to make sure you did everything. So graph the relation 2, 2, which would be over 2, so over this way, and then up 2, okay? So graph all that. So we have to go over 2, up 2, which would be here. My lines and my numbers are not actually lining up perfectly, but that's because I adjusted the size of the graph. Okay, so over 3 up 7 would be 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 really would be like way up here. Okay, negative 1, 5 would be in 1 and up 5, which would be right about here. And 3, 6 would be over 3, up 6, which would be just on the grid border here. Okay, and state the domain and the range. Okay, so the domain is all of the x values. So we just have to use a D here for domain, a bracket or a brace, and these are the x values. And you don't have to write all this out, but you do have to write the D, and we like to have a colon and the brace there. And it's going to be all the x's. So 2, 3, negative 1, and 3. We only have to list that 3 once. So I like to write them in order from least to greatest. So negative 1, 2, and 3 we only have to write one time. Then the range is going to be all the y values. So if we have a brace, we would use 2, 7, 5, 6. So 2, 5, 7, 6, or 6, 7, if you do them really in order. Just remember that if you're not accustomed to doing them in order, that if you take a multiple choice test, that you look to see, they can be out of order, which is fine. Okay, that is the domain, the range. All right, so find the value of g, the g function, when x is 2m, if g of x is, and this equation right here. So the g of 2m means that you're plugging 2m in wherever you see an x in your function. So equals, so let's do the 2m for that first x, plus 2 squared minus 4. And now we have to simplify this as best we can. The way you do that is just carefully with this one. If you have something in parentheses and it's being squared, you have to write it out 2 full times. So 2m plus 2 times 2m plus 2 minus 4. And the key here is to remember to FOIL. This is something that we see kids really struggle with. So please, we've emphasized this so much. Let's FOIL this. The firsts would be 4m squared. The outers would be 2m times 2, which is 4m. The inners, which would be 4m. And the last, which is 2 times 2, which is 4. And then a minus 4 at the end that we pull over from here. Okay, so then we combine like terms. So we have a 4m, m to the first power, m to the first power. So that is going to give us 8m when we simplify. This plus 4 and this minus 4 actually cancel out each other. And so then we just bring down the 4m squared in the beginning. And that's our final answer. And you might see it written as g of 2m equals, and then that whole thing there. And that's how you work with a function when they give you the value for x. Now, find the value of f when x is negative 2c. Hang on one second. Okay. Find the value of f when x is negative 2c if the f of x equals x minus 1 parentheses squared plus 1. So let's figure this one out. So the f of negative 2c equals, parenthesis, negative 2c minus 1 squared plus 1. Again, we have to write this out 2 full times. Negative 2c minus 1, parentheses, negative 2c minus 1, and then a plus 1. And then we FOIL. So the first would be a positive, I don't have to write the positive, 4c squared. First, then the outers would be these two, which would be positive 2c. The inners, which would be these two, is 2c. And the last, which would be those two, would be plus 1. And then a plus 1 from over here. Then we combine like terms. So this plus 2c and this plus 2c is 4c. Then we have this plus 1 and this plus 1, which is plus 2. Then we just bring down the beginning because there's no pair to go with that. And this is your final answer. And we can write the f of negative 2c in the beginning. That might be how you see it. And that's your final answer. 8, that should have been plus 2 and not plus 1. Okay, let's graph the piecewise function. All right, and this might be one of the most challenging problems we do, so pay close attention to this one. So the first thing we need to do here is graph the fence. So first is to graph the fence. Okay, and the fence is always right here. Always, always there. Okay, and so the fence is going to be at positive 3, and it's always on the x-axis. So the fence would be right here, and I will just draw a dashed line. This is our fence, and now we can move to the next step. The second step is to graph dots for the lines. Okay, so our first line, remember this we could also call y. Y equals negative x. Now there's no y-intercept here, but you can write in a plus 0 if that helps you. Okay, so we're going to graph that first line. So if we're graphing y equals negative x plus 0, we would start at the origin. Negative x means that the slope is negative 1 over 1. So we can go from that origin down 1 to the left one, down 1 to the right one, down 1 to the right one, down 1 to the right one, and keep going. Remember, we like to see that you have points on either side of the fence. You have points for the line on this side, you have points for the line on this side. That'll help you when you're trying to decide where your line is actually supposed to be drawn, on the left side of the fence or the right side. Okay, so for this problem, x is less than or equal to 3. All right, so if it's less than or equal to 3, we're going to be using this side of the fence for this line, which means that just what's drawn on that side is where we're going to be going. So we're going to go this way. Now the last thing you have to check is to see if this is less than or equal to. This is less than or equal to, so we're going to make a nice dark solid dot at the fence. Okay, and remember Mr. Vincent said you can erase that other point that you have there if that is easier for you to keep things organized. So you graph the dots for both lines. Let's keep going to the next one. So the next one would be y equals 2. Now, a y equals 2 line is a special line. If y equals 2, we're going to go to 2 on the y-axis, and then we have to determine if this is a vertical line or a horizontal line, and this is going to be horizontal. So all the values for y on all the points on this graph have to be a 2. So if we went over 1 and up 2, that would be this point. If we went over 4 and up 2, that would be this point. So our line is clearly going in this direction. Now we have to figure out which side of the fence we're on though. So for this one, x is greater than 3. So greater than means that we're going to be using the larger numbers, the higher side of the fence. We're going to go to the right, and since it's only greater than and not greater than or equal to, we're going to have an open circle there. Oops, an open circle at this point. And that is your piecewise function. So let's finish up with the rules, the steps. Graph the dots for the lines. 3, use the x values to decide which side of the fence that the line is on. It can only be on one side of the fence. Don't forget that. You cannot have any lines that go on the left side and the right side. So you use that inequality to tell you which side it's on. Okay? And our last step, I'd just like to remind everybody, is check for solid or open circle. A solid circle would be less than or equal to or greater than or equal to. An open circle would just be less than or greater than. Okay? Let's move on to the next page. Okay, so we have to find the line that passes through the point 3, 3 and is perpendicular to the graph of y equals 2x minus 3. Remember, we're going to be using the 3, 3 as the x and the y. If a line is perpendicular to another one, that means it's going to be the opposite sign, reciprocal, slope. And reciprocal means flip the fraction. Okay, so if this is the original line, we only take slope, not the b, so not the 3, okay? So if this slope was 2 over 1, we're going to use m equals 1 over 2, but we're going to make that negative. All right, so let's begin solving here. So we have to find the equation of a line that fits this y equals mx plus b format. So we're going to plug in this y over here, and we're going to plug in the x over here, and we're going to plug in the m that we have from our original equation, that negative 1/2. So y is 3 equals negative 1/2 times x, which is 3, plus b, which we don't know. That's why we're doing this step. We're solving for b so that we have the m and the b, and then we can write our equation. So negative 1/2 times 3, if we put this over 1, would be negative 3 over 2. Rewrite the rest. Now we would add 3/2 to both sides. These would go away, and b equals 3 over 2 is equal to 1 and 1/2. If we add 3 wholes to that, together we would have 4 and 1/2. Okay? And the way I got that 1 and 1/2 was 3 over 2. A whole would be 2 over 2. Then we would have 1 over 2 left. So this is a whole plus a half, which is 1 1/2. But remember, Mr. Vincent doesn't want you leaving these as as mixed numbers. So we're going to multiply that back out. 2 times 4 is 8, plus 1 is 9, and we have 9 over 2. So b is 9/2. Okay? So now we have the b and we have the m from before. We're going to use these two parts to come up with the equation of the new line. So the equation of the new line would be y equals m, which is negative 1/2, x plus 9/2. And that's what you need for that one. Okay, for the next problem. Find the line that passes through 2, -1 and is parallel to the graph of this right here. Now, for this one, we have to put the line equation in y equals mx plus b format first. This is not y equals mx plus b. This is what they call standard form. So we have to change that first. So we're going to subtract the 2x from both sides, and 3y equals negative 2x plus 6. Then we would divide by 3 everywhere you see a term. Y equals negative 2/3 x plus, and that would be 2. So we're going to just be using the slope from this problem. And since our line is parallel, we're going to use the same slope. So m for our new equation is going to be negative 2/3. Now we have to find the b. This is our x, and this is our y. So when we fill in to try to find y equals mx plus b, we're going to be looking for the b, so that's going to stay here as a b. The y is a negative 1. The m is negative 2/3. And the x is 2. Let's move that plus b. Okay, so we have to do a little multiplication here. So here we have 2 over 1. So 2 times negative 2 times negative, negative 2 times 2 is negative 4 over 3 plus b. Then we're going to add 4/3 and add 4/3. Okay, and 1 plus 4/3, we can convert this. 4/3 is 1 whole, and 1/3, sorry, that's negative. And this is negative 1. So the negative 1 and the positive 1 will cross out, and you will just be left with 1/3. And now we are going to take what we know is the b, take what we know is the m, and we're going to put them together. So now our final answer is y equals negative 2/3 x plus 1/3. All right. Next, we're going to go on to this inequality graph. Sorry. Okay. I'm going to go on to this inequality graph at the bottom of the page. Let's see if I can get this any smaller. Any more focused here? Okay. So we have to graph this inequality, and don't forget to shade. Okay, so let's make sure that we're making a point of remembering what we are going to have to be doing for this problem. So I'm going to bring this over here. Y is less than or equal to negative 2x plus 1. So let's graph that first. We're going to graph the b first, and then we'll graph the slope, which is the m. So let's go to positive 1 and plot a point for our y-intercept. And for negative 2 over 1, we'll go down 2 over 1, down 2 over 1, and keep going. Just makes it easier to draw the graph. Makes you more accurate. Okay, so this is going to be our graph. Now, before we fill in what our line is going to look like, let's double check that we're looking at our symbols. So y is less than or equal to the graph. So less than or equal to means that this is going to be a solid line. And when you choose a test point, we can choose 0 here because we drew a nice kind of neat graph there. So if our test point is going to be that 0, let's write that our test point is 0, 0, the origin, and we're just going to plug that in our original equation. So y is less than or equal to negative 2x plus 1. Let's plug in a 0 and a 0. So is 0 less than or equal to 1? Because this all goes to 0. We don't need that. Is 0 less than 1? This would be a yes. So we will shade in the area of our test point. We will shade down towards the area of our test point. Our test point was right there. And on to the next page. Okay, so just a few more to go, everybody. Okay. So graph all three functions on the same graph. These are absolute value functions now that we're graphing. So we have to remember that when they're absolute value, we're going to have a V shape with a vertex at the bottom. Okay, so let's graph the first one, which is going to be blue. The second one we will have as pink. And the third one we will make green. So back to the blue. Okay, so we have to find our vertex first. Our vertex for this one would be a negative 1, 5, and the negative comes from inside the absolute value, this being a positive 1. So we're going to use the opposite. We use the opposite of this first number and the same as what's outside. So negative 1, 5 would be over 1, 1, 2, 3, 4, 5 up here. That would be where our vertex is. Then we look in front of the absolute value and we look to see if that is negative or if there's a number there, and there isn't, which means that our slope is really just 1 over 1 and it's positive. So we're going to go up 1 over 1, up 1 over 1, and you could go as many times as you want, but you don't need to keep going. And then we would go up 1 to the left 1, up 1 to the left 1, and graph that as, draw that line as well. And there's our V shape. Okay. For the next one, we're making pink. We're going to pull out the vertex, which is going to be opposite of the first number, so it's going to be positive 2, and a negative 4 because it's the same as what's outside. Now here we do notice that we do have a negative out here, so if we put negative 1 over 1, we can use that as our slope for our one side of the V function. So 2 negative 4 would be over 2, but then 1, 2, 3, 4 down 4. And if our slope is going to be a negative 1 over 1, negative 1 over 1, and then we have to draw a symmetrical side over here because it's a V shape, then that is what our graph would look like. Okay. For the last one, we have a positive 6 on the inside, so our vertex is going to be negative 6. There's nothing on the outside, so we can use a 0. And since there's a 3 here, we will use the slope as 3 over 1. So we'll go negative 6 and stay at 0 on the y. And since there's that 3 over 1, we're actually going to go up 3 and over 1, up 3 and over 1, and the same thing on the other side. So just draw symmetrical lines, or put dots in the symmetrical shape on the left side to make a symmetrical shape altogether. Okay, and that is your absolute value functions. Remember, it's a V shape. That's really important to remember. It'll help you a lot with knowing what to do when you get to one of these problems. Okay, so then we have these three at the bottom. The first one is to solve the formula for f if 3d minus 2f equals 9. So we're solving for this f right here. So if we rewrite this a little bit bigger, 3d minus 2f equals 9, and we're trying to get that f by itself, okay? we're going to see what we need to do here. So we have to get rid of, we always get rid of what's added or subtracted to that term first. So let's subtract the 3D and subtract the 3D. This goes away. We're left with negative 2f equals 9 minus 3d. Then we have to get rid of the 2 because we want the f by itself. So negative 2 divided by negative 2, f equals 9 minus 3d divided by 2, and that's where you stop. There's no reducing for this one. There's nothing we can do about that. Okay, factor c cubed d cubed plus 27. So you need to remember and be able to recognize which factor methods we are using. So when you see those threes, you should automatically think that it could be a difference of squares problem or a sum of two squares problem. And if it is, we'll be able to fill in these two parentheses and say that if we cube those numbers, cube those values, we would get what's over here, what's up here in our problem. Okay, so if we have CD and we cube that, you would have C to the third power, D to the third power. If we take a 3 times 3 is 9, times another 3 is 27, and that works as well. Now, you have to remember what the model is for this problem. So the model is that we use our, if this is our A and this is our B, we use a single A here, then a B, and then there are 3 terms on this side. We use an A squared, we do a B squared at the end, and then the middle is going to be A times B. Okay, so then we'll talk about signs later. So if we are using CD as our A, CD would go here, 3 would go here. For A squared, it would be C squared D squared. For A times B, it would be 3 times CD, and B squared would be 9, 3 times 3. Now, these signs, you have to remember SOAP. Same, same, opposite, always positive. Okay, so the same as what's given here in the original would be a plus, opposite would be a minus, and always positive would mean plus. So this is same, opposite, always positive for the 3 signs, and you'll always only have 3 signs. Okay, let's look at this factoring problem. So this is old-fashioned factoring, but remember that when you're starting a factoring problem, always check GCF first. What happens if you don't is that your factoring may work out, but in the end you will still have more factoring that can be done because the greatest common factor was not pulled out of those values. So that could be another number that could be factored out. Okay, so let's see what we have here. This is old-fashioned factoring, so we have an AM rule. So we have to see what multiplies to negative 24 and what 2 values would add to make negative 10. So negative 24 would be 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's it. So which one of these, if we have to make a negative 24, which means the signs are going to be different, and the larger number is going to be the negative because our middle number 10 is negative. So the larger is going to be negative. So how are we going to make that if the larger is going to be negative? Which one of these would add to make negative 10? And it would be 2 and negative 12. Okay, so 2 and negative 12. So we're going to have an x in the front, an x in the front, One sign is positive, one sign is negative. If we're using 2 and negative 12, the 2 would go here and the 12 would go here. And that's your final factoring answer. Okay, so the last page, everybody. Just move this a little bit. Okay, so we are going to factor 5b squared minus 13b plus 6. And whenever you see a number in all three places, you would think that maybe you can check to see the GCF. So is there a GCF here? No, because 5, 13, and 6 do not have anything in common. So this is going to be the box method since you have a number out in front. Unlike the last problem where you didn't have a number out in front and that was just old-fashioned, this one is going to be the box method because of the number in the front, because you have three terms, and because you start with a squared value in the variable. Then you have a variable to the first power and no variable in the third place. Okay, so we're going to make our box. All right, and our 5b squared always goes in this top left box. Our plus 6, or our last value, always goes in that last box. What we figure out now is what goes in the other two boxes. So the way we do that is we still technically do the AM rule. So we multiply these two and we still have to add to make this middle value. So 5 times 6 is 30b squared. Sorry, 5b squared times 6 is 30b squared. We have to see what will add together to make negative 13. I should have put that someplace else. We're going to see what also adds together to make negative 13b. Okay, so 30 would be 1 times 30, 2 times 15, 3 times 10, 4, and 5. 4 doesn't go in, 5 does, and then we stop. We have 5 times 6, the last one. Okay, so we have to have a negative number when we multiply these two together, but the 30 is positive, which means both signs have to be the same and add to a negative number. So everything is going to be negative. Which one's going to add to negative 13? That would be negative 3 and negative 10. So that's what we're going to use, and we do have b's next to these also. Okay, that's what we're going to use in our other two boxes. So negative 3b, negative 10b. Okay, then we take our GCF and we put a number here, 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 and here. The signs that the number immediately touches is going to be the sign that you use for that value. So we're going to use a negative here, a plus for the 5b squareds, so it would be positive, positive. Down here we're going to have a negative. So negative 3b and 6 would be negative 3. 5b squared and negative 10b would be 5b. To the left over here, so we're going to do a b over here. And to the left down at the bottom, we're going to do negative 2. So our final answer would be 5b minus 3 in one parenthesis and b minus 2 in the second parenthesis. Okay, I'm sorry, b minus 3. Oh no, I'm right. Okay, so then we have these factoring problems at the bottom, and finally a vertical line test question. Okay, so when we factor here and we see that we have 4 terms, again, we always check to see if we have a greatest common factor, and we do not. Okay, but this is going to be a grouping problem. So for this problem, we're going to split them in half. We're going to see what the GCF is for the first half. Let's see what the GCF is for the second half. We're going to make sure what we leave in our parentheses is exactly the same, signs and everything. And then we're going to rewrite our problem to show the factoring. So let's start with grouping. So we're going to do the GCF of the first half. So what can come out of both of those? And we should see the a squared. So a squared can come out of that. When we take a squared out of that, we have an a left minus a 4 And then over here, we're going to do the same thing and see what can come out of these two, and it will not be the same thing as the first one, or else we could have done a GCF. So 3a and 12, we can take out a 3 from both. We'd be left with a minus 4. Now, if you notice, your parentheses do match, which is good because now you know that you have the right answer. So we're going to take the two outside numbers, and if we didn't take out a sign with that 3, it's going to be positive, and a minus 4 from the inside of the parentheses, that the two that matched. Okay, factor m to the 6th power minus n to the 4th. Now this, when you see m to the 6th, you might think of difference of cubes, but when you see the 4, you see that there aren't groups of 3 variables that can come out. So this is actually just a difference of squares problem. So if we took m and we cubed it, and that to the 2nd power, that would be a perfect square. And n to the 2nd power, if we squared that, that would be a perfect square. So in a difference of squares problem, because we have subtraction, we know that it can be difference because subtraction means difference. So we would use the m to the 3rd power in the front of both parenthesis sets, n to the 2nd in both second spots. One is positive, one is negative, and that's how you always do a difference of squares. It must be a perfect square number here, a perfect square like value there, and it must be subtraction. Our last problem is to define the vertical line test. And for the vertical line test, when you have a relation, which simply means something drawn on a graph, so it could look like this, okay, or it could look like this, okay. Draw some arrows for Mr. Vincent, who likes those arrows because they're accurate. And then we could have something like this, okay. So for when you have a relation, if you can draw vertical lines that only intersect the relation in one location, the relation is a function. Only in one location, I should say here. Only. Okay? So if we look at our graphs here, if I drew a bunch of vertical lines, okay, this line right here, I could technically say would not make this pass. This line right here would probably not make this pass if these are exactly on top of each other. Sorry, I can't make that pass. So this fails the test. No, it's not a function. Okay, this one here, if it's a parabola, these would all be angled out. So yes, this is a function. And if we drew all vertical lines here, in a bunch of places, this intersects one line would intersect in 2 places. So this would be a no also. Okay, everybody, you made it to the end of your review. I hope that was helpful, and I'll see you next week.